In this video, we will be looking at strictly increasing and strictly decreasing functions. So a function is said to be strictly increasing if each preceding y value is greater than the previous one. We can think about that as over an interval, if the x value of b is greater than the x value of a, then the function evaluated at b will be greater than the function evaluated at a. We can also think about strictly increasing in terms of the derivative, and we may consider a function to be strictly increasing over an interval if the derivative is greater than or equal to 0 over that interval. So if we have a think about what's going on graphically, we could come up with a graph. It might not have a rule, but each value of y is bigger than the next one. So that would be an example of a strictly increasing function. For a strictly decreasing function, we find that each preceding y value is less than the previous y value. So a function that's strictly decreasing over an interval, you would have for every b that is greater than a, the function's value evaluated at b would be less than the function's value evaluated at a. In terms of a derivative, we may consider a strictly decreasing function to have derivative values that are always less than or equal to 0 or negative or 0. Once again, we could consider what's going on graphically. So we could have, again, just a function that doesn't necessarily have a rule, but as long as each y value's smaller than the previous one, we could consider that to be a strictly decreasing function. And an important note, for a function to be considered strictly increasing or strictly decreasing, the derivative does not necessarily have to exist for all values of x over an interval. There may be parts of the graph that aren't differentiable, but that doesn't mean that it's not strictly increasing or not strictly decreasing. Next up, we'll look at an example. So for the function shown, all the stationary points have been labelled with their coordinates. State the intervals for which the function is strictly increasing and strictly decreasing. So if we look at part A, we want the strictly increasing parts of this function, and that is when each preceding y value is greater than or bigger than the previous y value. So that means that as x increases, y increases, and this part of the graph satisfies that requirement, as well as this part of the graph here. So as an interval, we can write this as x is an element of, and it goes from negative infinity, not included, to negative 3, which is the x value here, and that point will be included, so we use a square bracket, union with this 1 here, which will be included, all the way to positive infinity, not included. The remainder of the graph, which fits in here, is considered to be strictly decreasing. And that's because each preceding y value is less than the previous one, or as x increases, y decreases. And we can write that interval as x is an element of, and it goes from negative 3 included to 1 included. So they are the intervals where this function is strictly increasing and strictly decreasing. So after this video, you should be able to understand the criteria for a function to be strictly increasing or strictly decreasing over a given interval or its maximal domain, and you should be able to state the intervals over which a function is said to be strictly increasing or strictly decreasing.